Okay, good morning, everybody. Thanks for joining us at ST Litrano section for this webinar regarding the food-grade lubricants. My name is Behshad Sabah. I work for Petro-Canada Lubricants. I have been working in the lubricant world for about 25 years, out of 27 years of work background. During that 25 years, I worked for different lubricant companies, different locations, but most of them I was involved in technical part of the business. I'm a mechanical engineer, licensed as a PEng in Ontario since 2008. I am the CLS OMA1, OMA2 certified by STLE and CAT1, CAT2 vibration analyst by CMVA and VI in US and Canada. I've been working as a member of board for ST Litrano since 2009. And as I said, since 2020, I am the chair, and May 2023 will be the last month of my operation there. The presentation that I have today covers the basic and general information and general review of the food grade lubricants. I'm not going to talk about the specific product with the product name and properties and stuff, but I try to cover the base oils and the basic of this business. We will look at the risk of not using food grade lubricants, some regulations, approvals, and expectations. We will look at the type of food grade lubricants, food grade lubricant market, and lube specification based on the application. Okay. So, what is the risk of not using food grade lubricants? There are 4 identified risks. The first, all of them are important, so I don't say which one is important. Has more importance compared to the others. So the first one is public health issue. Most of the time, these issues will be detected at medical centers, and the risk and damage for the company, the food company, is public awareness and brand damage. So if such a thing happens, the newspapers will talk about it, TV news will talk about it, and that's not good for the business. The other risk is product recall and its cost, which means at a store level or production level, you notice that there is a contamination, and you have to recall that product, and you have to eat and observe all the costs. Costs are like the storage costs, shipping, notifying the public, destroying the contaminated food, and so on and so forth. The other risk for us is operation shutdown and its cost, which means if the QA or QC or during an internal audit, the plant by itself notices that there is a contamination with the lubricant or any other contamination, then the loss of production, they have to shut down the line. They have to remove all the processed food or not processed food raw materials. They have to do all the sanitation and cleaning and then bring back to production. So all of these costs will be as a burden on the shoulder of the company. And the last one is the government fines. So when the government or government bodies, they come for the audits and they notice that there is a contamination or issue or not using any food grade lubricants, there will be some fines involved, plus corrective action that the company should take. So we use food grade lubricants to avoid from all these costs and issues and problems. Laws and regulation by country they are different from one country to the other country or from the region to the region. In Britain, we have British National Formulary, or NF, they call it. In Germany, we have German Food and Commodities Law. I cannot pronounce and read the German word, so I excuse myself for that. In European Union, we have European Food Safety Authority, And there are some official papers. I don't read all these things. You can have a copy of this presentation. So, so the European Council concerning food hygiene is 175, and then food processing machines, safety and hygiene requirements, and machinery intent for use with foodstuff and feeds. So European Union has its own rules and regulation. Some of these regulations are above and beyond the others. So there are some particles in German um, regulation, which is not a part of European Union regulation. So if somebody wants to do a business in Germany, should consider both. NSF is also acceptable in big part of Europe. So that's another thing that you should consider if you want to do a business in that region. In North America, we have different bodies. We used to have USDA, United States Department of Agriculture, and the application processing of USDA was shut down at 2004. And then after that, NSF, or National Sanitation Foundation, start the application processing, and they adopted almost all of the USDA categories except one category that I will explain later which one is it. CFIA, Canadian Food Inspection Agency, they stopped the application processing in 2014, and they only issue non-objection letter these days. The reason is they didn't have the right amount of people to go through all the applications. They were very slow, and there was a big backlog of the applications there. So you submit the application there, it took probably a year or two to get something from out of CFIA, which they couldn't handle. So they dropped it at 2014. We have FDA in North America, Food and Drug Administration. They have 5 subcategories for the food grade material. There is a 3570 component used to manufacture H1 lubricant must comply with this one. We talk about it more later on. There is a 3620 white mineral oil in non-food articles in contact with food. Just think about the packaging, the pizza box that you have that goes into this category. 878 UPS white mineral oil for direct contact with food, like any food release. In bakeries, they use it, so it goes with this one. Synthetic base oils, 882, like PAOs, should follow this article. And then subheadings like recognized safe substance, zinc oxide, and vitamin E goes with 182. So technically, FDA covers everything in contact or inside food, additive or mineral oil or synthetic. They have some sort of guidelines for that. If you want to know what product is approved by NSF, that's pretty much easy. You go to the Google and type NSF approved lubricant list, and then Google will take you to this link. And then this is a very, very long list. So from the top to the bottom, you can find all the products approved by NSF. And as you see, if you click on the name, the website opens the actual approval letter. If you click on the designation on the right-hand side, it opens a table to explain for what category that product is approved. Is it H1, H2, H3, or these are the additives like HX1, HX2, or HX3. So depends on the category of the category of that lubricant for the application. You will get the approval letter, updated one from the website, because a lot of time when you ask a supplier to send you the NSF approval, they just send you whatever that they have, which sometimes this is outdated, but you can go to the NSF approval lube list directly and get it from there. So the updated version. The other laws and regulation, that's either GMP, Good Manufacturing Practice, or HACCP. Good manufacturing practice covers operating instructions. It talks about training personnel, supervisors, and maintenance team, and how properly machines should be serviced and maintained. In good manufacturing practice, you will see mostly details about operation, like even at a washing station, what should be the water temperature or what should be the lighting inside and outside of the plant. So good manufacturing practice covers a lot of things, not only lubricants and chemicals. On the other side, we have HACCP. HACCP has two sections, hazard analysis or critical control points. In HA section or hazard analysis, the goal is to identify the risk and evaluate the probability and extent of the risk. So this is the HA section of HACCP. And then on a CCP, critical control point, the goal is to control risk by checkpoints, checking the location, procedure, process, and practice. And the final goal is to make sure the risk is contained or risk is reduced. And also determination of tolerances and controls will be set by the CCP. So technically speaking, in part one, we look at the risk, evaluate it, and then on part two, we set criteria and tolerance and controls to make sure that the risk is contained and reduced. So this is the HACCP responsibility. I don't go through the HACCP training. That's a big training by itself. People go to the college for that. But just an overview, HACCP covers 7 principles. And on the chemical side, on a workplace side, you see the cleaners and sanitizers and lubricants. So this is the place that HACCP will look at the lubricants and cleaner or sanitizers that are used in the production line. You can get a lot of education by looking at HACCP principle training videos on YouTube or any other colleges that is close to you. So what values we need for the food grade lubricants? Like any other lubricant, we expect them to reduce friction. We expect them to prevent and reduce wear in the system. We want them to protect parts from corrosion and rust. We want them to be a good heat transfer media so they can move heat from the friction area, hot area to the cool area. And then if the application is the bearings, we want them to be internal and external sealing of a bearing. Plus that, they should be food safe, like H1 and or 3H category, NSF category approved. We will talk about H1 and 3H later, so you see what are the differences. So on the top of those general requirements and the values of the lubricants, a food grade lubricant should answer and be ready to be used in different harsh environments. So from left to the right, they should be resistant to the food products contamination, like amino acids or bases. They should be resistant to beverage contamination, like fruit juice, milk, sugar, wine, the acidity of the fluid. They should be resistant to the hot and cold water during the production and cleaning or sanitation. They should be chemical resistant to some gases. If there is any fermentation, CO2 goes to the pops and cans. So any sort of gas generated during the production of the food or used for any reason in the food processing. So the lubricant should be chemically resistant against them. They should be resistant to the cleaners, detergents, and during the sanitation process. They should be resistant to disinfecting material like acetic acid, and they should be at the place during the steam cleaning. I explain about a couple of them later, and they should be compatible with plastic and other surfaces. So the main point is one of the main differences of the food industry compared to the other industry is the cleaning and sanitation. A meat processing plant or a chicken processing plant, they power wash and sanitize their chains twice a day. So you can imagine if they are going to use any chain oil, what happens to the chain oil when it comes to the contact with the hot water, pressurized water, or the steam, which may contain some sort of disinfecting materials or cleaners or any sort of detergents. So it should be very robust formulation to stay in place and do the lubrication. So that's the additional demands on the shoulder of food grade lubricants compared to the regular chain oil or regular gear oil. So let's talk about the classifications. So as I said, NSF adopted USDA procedure. USDA had H1, H2, H3, and then 3H and HT1. So they had one category more. And H3 was for soluble oils. So NSF dropped that. They only adopted H1, H2, 3H, and HT1. H1 is acceptable for incidental food contact. H2 is definitely no contact with food. 3H is for food processing substances and release agents. HT1 is for heat transfer fluid acceptable for incidental food contact. So all of the like a soup manufacturing plants or a stew manufacturing plants, they use heat transfer fluid to cook the food inside the kettle. So we need the HT1 approved oil for those application. There is a new food grade heat transfer system flushing fluid in the market, because anytime that you want to change the heat transfer after 5 years, 10 years of operation, depends on the health of the oil, you need to clean and flush the system before you fill it with the fresh heat transfer fluid. So this flushing fluid is new to the market with the NSF approval for that application. There are other approvals like kosher and halal, which are, they have their own procedure. They have their own body of registration. So I'm not going to cover that. But for us, H1, H2, 3H, and HT1, these are the categories that we mostly worked with. If we want to identify when and where we need H1, H2, or 3H, I think these two pictures can help us a lot. If we look at the production line, in this line, this plant is making like cookies, something like that. So anything above the production line or at the same level of the production line, we need the H1 product, because if there is any leakage, any drop, any spray on the food, so that's okay for the incidental food contact. Anything below the product line, which works under pressure, like a high pressure hydraulic system or any sort of pressurized lubricant system, you need the H1, because if the hose bursts at the bottom of this conveyor and sprays the oil upward on the top of these cookies, then we will have the food contact. So anything above at the same level need H1. Anything below the line pressurized need H1. Anything below the line which is not pressurized, you can use H2. Like if you have an electromotor down here or just a simple gearbox, no lubrication system, then you can use H2. 3H on the other side is like a mold release, like a release agent. So if a company making eggs and bakeries and something like that, so they put the oil on the pan to prevent the material to stick to the pan, it could be 3H. So mostly 3H does a cooking oil It's like the cooking oil that we have in our houses. So again, above the line, at the level of the line, pressurized under the line H1, under the line, not pressurized H2, and then 3HE is like a release agent for the food from the mold or from the pan. Okay, so now let's talk about 4 different groups of base oils that we use to manufacture and formulate the food grade lubricants. The first one is vegetable-based lubricants. These vegetable-based lubricants, they come from the vegetable oils, come like soya, sunflower, cotton, and they are used simply because they can get approved by NSF for H1 very, very easy and almost immediately, since these oils are eatable. So one of the advantages of vegetable-based lubricant, they get easily approved by NSF H1, so you don't have to wait a lot or do a lot of paperwork. And for industrial use, the only thing that supplier needs, they just get the oil from the production facility, filter it, and that's ready to go. You don't need to add a lot of or send it through a deep chemical processing to make it ready. So they are low priced, so they are cheap, but for the disadvantage part of it, because they don't have any additive in them in their formulation. So these lubricants have no mechanical properties like wear prevention, no efficiency on corrosion, coefficient of friction is very high, almost no resistance to water. So in a lot of application, we need to protect against corrosion. We need to reduce the friction. We need to be resistant against the water contamination. And as we see, vegetable-based lubricants as is, they don't cover these demands. These lubricants are a source for bacteria growth, and therefore their service life is very short, approximately 6 months. Yeah, 6 months, even the shelf life is short. So we all know that vegetable-based lubricants are biodegradable, which means in a period of time, with the attack of bacteria and mold, their structure will fall down and they will be degraded. So for that reason, these lubricants are source of bacteria, and the shelf life or service life is very short. The effective working temperature of these lubricants are around 60 Celsius. Just think about the cooking oil that you use in your house. You know, at the start, they are very shiny, golden, transparent. You put it in the pan, a couple of minutes later, they change to the dark brown, sticky oil because you heat them more than 60 Celsius. So they are not good lubricant above the 60 Celsius. They are very early and quickly oxidized, which explains the darkness and the stickiness of the oil in the pan, and their natural viscosity is very low, and they are not easily separated from the water. So yeah, they get easily approved and they are cheap, but they don't have a lot of properties to act as a lubricant. If we want to additize them, you know, have a formula, add some pour point depressant or VI improver or rust and oxidation additive, it's possible, but then the price will go up. And so it seems that we start with a crappy base oil. Now we want to add a lot of additives to improve the properties. So the price will go up. And at a point, it's not economical anymore. And then when you add the additives, it's not easily approved by NSF H1 anymore. Then you have to submit all the formulas and the process and finished product for the approval. So if you don't use the additive, you don't have a lot of advantages. If you use the additive, you will lose the advantages that you have already. So That's a challenge of using vegetable-based lubricants. The other type of base oil for the food grade lubricant is the white mineral oil or mineral oil non-additized. So white oils are mineral oils with different grades of refining and different grades of purity, like DAB 8, 9, and 10. And these oils are in fact paraffinic base. They are approved by FDA. It's a very high grade of purity. They are in a very high purity grade of they are used as base mineral for cosmetic and pharmaceutical products. They have some advantages using mineral oil non-additized. They get easily approved by NSF H1, so that's good. They have lower coefficient of friction compared to the vegetable-based product. They have higher level of wear protection, which is good. We like that. They are easily separated from the water depending on the refining process. There are different type of refining process in the market. So again, that's better than vegetable oil. They are better, but not enough to give positive result for saving parts and extended lubricating intervals. So they are good compared to the vegetable oils, but they are not the best in the market. The disadvantage for these mineral oil non-additized is if we use them to formulate food grade grease, greases are aging after a short time and lose their lubricity. They usually dry because of the low base oil viscosity due to the high bleeding, and they have poor viscosity temperature properties. So when we talk about grease bleeding, it means that the oil will separate from the soap. And there are several different reasons. One of the reasons is the more base oil content in the grease, you have more bleeding. So if you have like NLGI 0 against NLGI 2, you see more bleeding on NLGI 0. If you have lower base oil viscosity, if you have two NLGI 2 greases, and then one of them has base oil viscosity of 35, the other one is 220, so you see more bleeding on the lower base oil viscosity. So because they have low viscosity, you see more bleeding, and more bleeding means the grease will be dry and will lose the lubricating property as it should have. So these are the disadvantages of using mineral oil when they are not additized. Now let's look at the mineral oil when we additize them. We use additives to enhance or add properties to the white oil, and lubricant manufacturer use different type of additive packages in accordance with the FDA and NSF regulation. So if I go back to this table, sorry, all the components used to manufacture H1 lubricant must comply with this one. So when we talk about additive being used, we talk about this regulation, and then regulation 182, safe substances, zinc oxide, vitamin E, it will be this one as well. So we should look at these two regulations when we formulate the product. So the finished product should also be approved by NSF under H1, H2 classification based on the finished lube application. So it's not only the raw material that should be approved, also the finished product should be approved by NSF. So we need to submit all this document to NSF for the approval. Now we can talk about the food grade lubricant based on the synthetic oil, polyalpha olefin or PAO. So as we expect, they have very good temperature viscosity behavior without the need to use high quantity of viscosity improver or polymers. So they have wide range of working temperature from -30 to, plus 100 or 110 or something like that. They have wide range of working temperature. We talk about that. Very low speed of oxidation, so they have longer life. Is not a source of growth and developing of bacteria. So on the other side, they are not polyalpha olefins are not biodegradable as like vegetable oils. Has a quick separation ability from water, which is very good. Water contamination is always there, especially when you wash down a system or a gearbox or hydraulic system. There is always a chance of water ingression into the system through seals or breather or any cracks or any holes anywhere in the system. They have low coefficient of friction and very good protection against wear. Again, these are two main characteristics that we are looking in a lubricant. They significantly extend lubrication intervals, so you don't need to change them every 6 months or every year. You can put them under the oil monitoring process, take the oil samples, look at the properties, look at the contamination, look at the viscosity, acid number, then you make a decision if you want to change the oil or not. And they have excellent adhesion to the metal surface, especially in friction points. So technically, they have a lot of advantages. They're almost the ideal lubricant for our system. But let's look at the disadvantage that they have. Products are expensive, but if you look at the total cost of ownership, you buy them very expensive at the beginning, but instead of changing them every year, you change them every 2 years or 3 years, depends on the application. So you buy less, you have less waste to dispose, you have less maintenance to do. So the total cost of ownership most of the time is less than the extra price that we pay for the polyalpha olefin or any synthetic products to be used. So food grade market, we are familiar with a lot of these applications and plants like meat and poultry, dairy products, beverage production, bakeries, fruit and vegetable preserving, sugar and confectionery manufacturing, and corrugate manufacturing. So the only item that I think probably we are not 100% aware is the last one. The rest we know, we go and we see it on the shops, on the shelves, we buy them, we use them. But corrugated manufacturing is the process that when you order a pizza, it comes in a box, and that box should, when they manufacture that box for the food industry, they should use food approved and food safe products. So when they package the food inside that box and the food comes in direct contact with the box, they will not be any sort of like contamination which put public in danger. Years ago, if you look at the company's food grade products, especially on the grease side, you see they don't use any lithium base grease. They don't have any lithium complex. They don't have simple lithium or single lithium greases. And the reason was the fact that lithium was used and is used as like some medication for depression. And they had this fear that if they allow lithium-based grease to be used in a food plant and there is a contamination with that lithium grease on a food or package, and somebody eats that, and then that lithium contamination will cause some health issue for that person. But recently, about a year ago, a company in Canada came up with a new formulation for the lithium-based greases, and it's approved by NSF. So probably in the close future, we see that everybody is using that, because at this moment, we don't have lithium-based grease. So that's an example how a cross-contamination from a lubricant can affect the health of the people. But now with the new technology, they have generated this new material which is safe to be used. So for for all of these plants that we have here, all of these operation and applications, we use hydraulic oils, compressor oils, greases, and so on and so forth. I think all of them are, most of them are well known by the audience. A couple of them I explained, like food cutter fluid is the fluid that's used for the knives that cut steaks or cut meats. So you keep them sharp. So you reduce the friction there to save the blade. Silicone and non-silicone spray, they mostly used, well, they have a different application, a wide range of applications, but they also use for the steel hooks when they hang the meat or chicken to those hooks. They spray on the hook to prevent them from rust and oxidation. So as you see, a lot of applications at different temperature, different contaminations, acids, bases. We should have a formulation for them. From my point of view, as a technical person, when a customer comes to me and asks me about either a product recommendation or oil and grease replacement. You know, sometimes they say, okay, I'm using from company ABC, what you can offer, or I have this application, the equipment is brand new, we don't have any choice at this moment or any options, what you can recommend. So for both of them, when I want to recommend a product, I go through some steps, I explain them to you, and then I explain why that's important. First of all, I will look at the OEM recommendation, if there is any. That tells me a little bit about what chemistry has been accepted by the OEM. You know, if there is any um, um, seals or gaskets which might have compatibility issue. So I will look at it. Then I will look at the warranty of the equipment, if the equipment is still under warranty or not, and when that warranty will end. Then I will look at the NSF or other governing bodies regulation. Again, if the system is under pressure, under the production line, or that's just above the production line. So that helps me to pick H1, H2, or 3H product. Then I look at the workplace health and safety. If there is any worker there who has some sort of a skin problem or any health issue with any sort of like polyalpha olefin, let's say. I haven't heard anything like that, but just as an example. So if there is any health and safety issue on that plant, then I will look at the operation, like what's the temperature? Is it a gearbox running at 80 Celsius, or that's a hydraulic system at 75? Then I will look at the loads of that gearbox or the bearing, axial load, vertical load, forces and stuff. Is there any shock loads involved? Then we look at the chemicals. Again, is it like a packing or bottling of lemon juice, which is very acidic? Or is it for milk? Is it for a hot soup that they are packing or something like that? So we look at the chemicals which may ingress into the oil or grease. We look at the speeds, like the RPMs, reciprocating speeds or rotary speeds. And then at the end, we will look at the waste disposal regulation for that specific location. What are the government requirements for the waste disposal? And putting all these things together with the limitation that we have for the base oil type, for the additive package, for CF, for the NSF and FDA regulations, we try to find the best product which can serve the purpose and do the job. So this is the whole process that we go through to either replace an existing product or recommend something which hasn't been there before. So By that, that was the material that I had for this presentation. Please, if you have any question, unmute yourself and ask. I hope I can answer that question, or you can type your question in the chat so I can read it. Thank you very much. Okay. So, okay. So I don't see, let me stop the recording.